All right, this is the Geometry Unit 3 Lesson 1 video. You'll notice we skipped Lesson 2. That's because we're doing the project version of the course, the pro version of the course. So we will do a project at the end of Unit 5. So we'll do Units 1, 3, 4, and 5, and then we'll do a project that'll take a week or less. So I think that will be a better route for everybody to take as opposed to doing Unit 2. I just highly recommend that for everybody. And when we get there, I'll put out more information about the project. I think it'll be pretty doable for everybody. So a lot of information in Lesson 1. So I'm going to kind of break it down into three parts. The first kind of big idea that we need to talk about, is to talk about the different ways that lines can be related to one another. So that's kind of what this whole lesson is about line relationships. In fact, the whole unit is about line relationships. So I'm going to start by just going through kind of 5 main line relationships that you need to know about. So we're talking about the relationship between two lines. And so the first one is kind of the most straightforward one, which is when lines intersect. So intersecting lines, also known as concurrent lines, are lines that intersect. And we already know from our previous unit that when two lines intersect, they intersect at one point. So that's one way lines can be related. Within that category of intersecting lines, we have one special type of intersecting line, and that is when lines intersect and form a right angle. When that happens, we call it perpendicular. That's when lines intersect to make a right angle. And you'll see that marked with the box like you see here on the notes. So that box tells you that those lines intersect in that particular way. So these lines still only intersect in one point. All right. So that's the second type of angle relationship. Third main type of angle relationship is lines that do not intersect. So there at no point do these two lines cross, and this is known as parallel. And these are kind of the main ones you're going to come across most of the time. And these are the ones we deal with the most in geometry. But there are 2 other types of line relationships. One is what happens when you have lines that are the same, essentially. So in other words, they both cross the same set of points. When that happens, we call it coincident lines. So again, this is the same line, right? So there's no real way to distinguish between the two. They cross the exact same set of points. All right. And then lastly, we have kind of a unique case. That's what we call skew. Go and write down the name first here. So skew lines are difficult to draw on a flat surface, but I'll try to post some diagrams in the notes, but understand that it's like, imagine, I think the best way to understand this is like, imagine you have a road, and then you have another road going across, and there's like an overpass, right? And so that overpass kind of exists on a separate plane above this other line, right? So it's like, and I'll kind of, let me actually do this in a different color. And maybe it'll help kind of like visualize this. But we have these 2 lines exist separate from each other. They don't intersect, but they also aren't parallel, because parallel lines exist in a plane together. Skew lines aren't in the same plane. So like I said, the example here is like an overpass going over another roadway. And so skew lines, another way of thinking of them is they are non-intersecting but also not parallel. So they are in different planes. So that's kind of some extra information there. So like I said, we're mostly going to work with intersecting, perpendicular, and parallel lines in geometry, but we are going to deal with coincident and skew lines in the lesson that we're working on right now. So we're going to pause that and come and check out the way that these questions are going to be asked of you in the lesson. So first things first, you have some vocab here. These are just basic definitions, numbers 1, 2, 3, 4, 5. 1 through 5 or 1 through 6, it looks like. Yes. Yes, 1 through 6 are vocabulary that deal with what I just went over. Okay, so I'm going to go and write that down here. So all of this comes for questions 1 through 6, but also if I jump down, I know that I'm jumping around a little bit. It also deals with numbers 12 through 15, and then these other ones as well, 16. So let's just look at these real quick and let me help you understand what they're asking you. So basically they want you to take this situation of this map of these roads and apply these different relationships that we just talked about, intersecting, perpendicular, parallel, coincident, and skew, to these roadways. So for instance, what's the relationship between Cherry Boulevard, which I see is right here, and Elm Avenue? Okay, so you should be able to see right away that those lines cross right there. And so you should choose the answer choice that corresponds with lines that form that pattern. So that's literally all you have to do for questions number 12, 13, 14, and 15. So those are all going to be looking at this and deciding what relationship those pairs of lines relate to. Okay, so let me just start this. So that's going to be, what did I say, 12 through, and then starting in number 16, you have this cube, and then they want to know, like for instance, which pairs of lines are concurrent. Okay, well, concurrent refers to any intersecting lines. So there's a lot of examples of intersecting lines here in this diagram. These lines intersect. These lines intersect. Tons of different pairs of intersecting lines. So you just need to find which of these pairs listed is an example of a concurrent line pair. Okay, so you just need to find lines that intersect. Remember, concurrent means intersect. Same thing with the next question. Now they want to know lines that are perpendicular. I'll draw your attention to these that show that those are perpendicular lines right there on the diagram. So I'm going to pay close attention to that. So really, I can tell you right now, all of these intersecting lines here on the front of the diagram are examples of perpendicular lines. So you should be able to get that figured out. So those are your perpendicular areas. So take a close look at those two intersection points. Again, mark the two lines that are perpendicular. What about lines that are skew? So this is a great example. I'm not sure if I'm doing one of the examples they have, but lines that would be skew in this diagram would be like RS and MN because they are in separate planes. Okay, maybe I don't know if I actually chose one of the right answers, but I just want you to see an example. Another example might be PM and QR. Those lines are skew. They're on different planes. So find examples of a pair of skew lines. Keep going. 19. Parallel lines. Find a pair of parallel lines. And then what is the measure of the angle formed by MN and MQ? Well, we talked about that. That's a right angle. If you go back over here, remember perpendicular means those are intersecting at 90 degrees. So that should help you with that one. So that's everything through question number 20. And the rest of this is going to deal with a different concept. So we're gonna pause there and come back. So let's write down that so I remember through number 20, so you know. 1 through 6 and 12 through 20 in the lesson apply to all of that stuff up there. Now, the next set of problems deals with this concept of a transversal line. And actually, the next lesson is going to deal with transversal lines as well. So a transversal is when I have two lines, especially parallel lines, and another line cutting through them. This line, and we'll call it line T, is what we call a transversal line. And it does some things to this situation. The first thing it does is it separates this diagram into the interior area between the other two lines. We'll call these lines, we'll call it line M and line N. And it also separates into the exterior. So basically, everything out here is exterior, and here. And everything in here is the interior, right? So that blue area is the interior. So again, this extends out to here and here and here. So it extends all the way through the diagram. Maybe I should indicate that some other way, but that's okay. So interior and exterior, that's the first kind of big concept you need, okay? And then lines, angles are related based on whether or not they are on the same side of the line or alternate sides of the line. So I'm going to draw some numbers in here. So let's say we'll call this angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. Okay? So 1, 3, 5, and 7, these are all on one side of the line. And on the other side of the line, I have 2, 4, 6, and 8. Okay? So anytime I'm looking at 1, 3, 5, and 7 together, they would be called same side. If I looked at 2, 4, 6, and 8 together, any pair of those would be considered same side as well. But if I pick one from 1, 3, 5, 7 and another angle from 2, 4, 6, 8, like 1 and 6, those would be considered alternate. So they're not on the same side of the line. So we have kind of two concepts here. We have, are the angles exterior or interior? Are they on the same side or are they on alternate sides? Okay, so I'm going to jump over to the lesson here and look at kind of what they do here. So see, they've described a little bit of what I've shown you right here, here in this diagram, and then they start to walk us through the different types of relationships that we find when we look at this situation. Okay, so I'm going to do that for us. I'm going to walk us through each angle relationship. So let me jump down and draw another one of these transversal line things. So the first type we're going to look at is alternate interior angles. So remember, alternate means they're on opposite sides of the T line, and interior means they're on the inside. So the pair of yellow angles right here and right here would be an example of a pair of alternate interior angles. They are both on the interior, but they are on opposite sides of that line. We also have another pair of alternate interior angles. This green pair of angles, this angle, and this angle are also alternate interior. So each of those pairs would be examples of alternate interior angles. Let's keep going. So it begs the question, what does alternate exterior look like? Alternate exterior angles are going to be angles that are opposite each other, but in the exterior of the diagram. So this angle and this angle would be an example of an alternate exterior pair. Similarly, this angle and this angle would be an example of an alternate exterior pair. So again, alternate refers to being on different sides, interior or exterior. Okay, let's go on to the next set. So what about same side? Okay, it's our T line right here. So what about same side interior and same side exterior? Okay, well, same side interior means that lines are on the same side of the transversal line. So it would be like this angle and this angle. These angles are on the same side of the T line, but they are both on the interior of the diagram. Same side interior. And then flip it the other way. This angle and this angle are on the same side. The other side, they are same side interior. So same side exterior is going to be a similar concept. We're going to have this angle and this angle. They are on the same side of the T line, and they are both on the exterior. And so then my other pair to go with that is going to be this angle and this angle. All right. So that's kind of what they're walking us through here. They walk through the same exact information I'm going through right now. But then there's one other one we need to talk about, and that is corresponding. So corresponding is a little bit of a different concept, but let's go ahead and draw another diagram here. Let's say we have these. It's my T line. So corresponding means basically located in the same position of the intersection. So in other words, if I look at this intersection and this intersection, and I look at the same position, what I mean is this. This angle here is located in the same position as this angle here. In other words, if I were to kind of slide down this top angle here, it would slide directly into position with that other angle. So you can kind of see how they match up with each other. And that's kind of the concept behind corresponding angles. So corresponding angles look like this. So there are 4 pairs. There's the pink pair that I've already drawn. There's this orange pair here, where you can see they are in the same position. We have a pair here. Those would be corresponding angles. And then lastly, we have a pair here. So you can see those 2 sets of angles have a match with each other, depending on where they are located around that intersection point. And that's the concept behind corresponding angles. So these are the 4. There's a summary right here. You need to definitely know these definitions right here, because that's what they're going to be looking at in the vocabulary. So starting in number 7, I'll write that down. So we're dealing with number 7 through, I'm not sure, let's see, 7, 8, 9, 10, and 11 are all going to deal with that. So again, I'm telling you 7 through 11 are going to come from the material we just went over. So you need to read the definition. Pairs of angles formed when a transversal intersects 2 lines so that they lie on opposite sides, alternate, of the transversal and between the lines, interior. Look, I just did that one for you. So the key words here are either opposite side or same side, and then between the lines or outside the lines. So between the lines would be interior, outside the lines is going to be exterior. So there's number 10 for you right there. That one's made pretty easy. So just read those definitions carefully and match them up with the definitions you have in the unit or using the diagrams we went over. All right, Then we already did 12 through 20. And then we get down to number 21, I believe. Yep. And it just is straight up asking you, find a pair of alternate interior angles. So interior, that's obviously in here. So we're going to be looking at the angles that are in between the two lines. So the pair of angles I'm looking at has to be inside and alternate. So I'm going to let you do these on your own. I think if you just look back and forth between our different example diagrams, like alternate interior, you should be able to find an angle pair from that diagram that matches the pattern we went over under alternate interior, alternate exterior, whatever it is. So that's going to be 21 through the end, through 25. Okay, let me write that down so you know which questions go with what concepts, 21 through 25. So there's a lot of questions in this lesson. Hopefully, a lot of that makes sense. We'll be going over more of that in the next lesson. But that is it for lesson 1.